So in the previous video, we were discussed about relationship between impulse and momentum. And impulse is, we have seen that impulse is equals to change in linear momentum. In this video, we discuss the measurement of impulse by graphical method. Measurement of impulse by graphical method. Measurement of impulse by graphical method. The first case we discuss when a constant force acts on a body. When a constant force acts on a body. When a constant force acts on a body, then we find the measurement of impulse. So suppose a constant force acts on a body for time t1 to t2. Let a constant force F acts on a body from time t1 to t2. From time t1 to t2. Up to time t2. From t1 to t2, a constant force F acts on a body. So its graph is time always taken on x-axis. Time is taken on x-axis. This is time axis and this is the force axis. On y-axis we take force and on x-axis always we take time. Since force is constant, therefore the graph will be a straight line parallel to the time axis. Let this is time t1 and this is time t2. And since there is a constant force, so the graph is a straight line parallel to the time axis. Since constant force acting on a body from time t1 to t2. So let this point as A, B, C and D. A constant force acting on a body from time t1 to t2. So it is given by a straight line graph. This graph, this line, a straight line AB, shows that there is a constant force acting on a body from time t1 to t2. So for finding the impulse, we find the area of a rectangle ABCD. Let the force is F, constant force acts is F. So we find the area of a rectangle ABCD, which is equals to length into breadth. So AD into DC, AD into DC, and AD is equals to F and DC is equals to, this is time T1, this is time T2, so for this much time CD, T2 minus T1. This is whole time T2, this is time T1. So for getting this time interval, we will subtract from T2 to T1. So AD is equals to force and DC or CD is equals to T2 minus T1. So F into T2 minus T1. And we can represent, we can suppose this T, so F into T. And we know that force into time gives the expression for impulse. So area of the graph gives the expression for impulse. Area of the graph, F into T. Area of the graph gives the expression for impulse. And when the variable force acts on a body, the second case, when a variable force acts on a body. In the first case, the force was constant. If the variable force acts on a body, then the graph will be like this is time axis, and let time T1, T2, this is force axis. So the graph would be like T2 time. A, B, C. At every time the force gets changed. This is the variable force. And this area will be the impulse. So when a variable force acts on a body, then the graph of a variable force, when acting on a body, then the graph of impulse will like this. Now, we talked about the application of the concept of impulse. But before discussing the application of impulse, we will discuss a short concept. We know that impulse of a force is equals to impulse of a force is equals to force into time, and in turn it is equals to change in momentum. Change in momentum means linear momentum. Already we have seen that impulse of a force equals to force into time, and which is equals to change in momentum. Let us suppose if two forces F1 and F2 acts on a body, if two forces F1 and F2 acts on a body, if two forces F1 and F2 acts on a body to produce same impulse. There are two forces F1 and F2 which acts on a body to produce the same impulse. Then their time durations T1 and T2. Then their time duration. Then their time duration T1 and T2 should be such that F1 into T1 equals to F2 into T2. Because impulse is same and force into time is equals to impulse, so F1 into T1 equals to F2 into T2. If time will be large, then the force exerted will be less. If the time will be large, we conclude from this expression that if the time will be large, the force exerted will be less. If from this expression we conclude that if time will be large, then the force exerted will be less. If the time will be large, then the force exerted will be less, and this concept we use in the application of impulse. We study in details about the application of impulse, but this is the only concept for the application of impulse, that if time will be large, time elapsed will be large, then the force exerted will be less. That is the reason while a cricketer catching the ball lowers his hand in backward direction. So the cricketer lowers his hand in backward direction to increase the duration of time. He increases the duration of time, and due to which he gets less stuck and less force will act on his hand, because duration of time he increases by lowering his hand, and he will get less force. So this application we will discuss in detail in another video. In this video we discuss few numericals based on impulse. Numericals based on impulse. And the first question is, a batsman hits back a ball straight. A batsman hits back a ball straight. Hits back a ball straight. A batsman hits back a ball straight in the direction of the bowler. In the direction of the bowler. In the direction of the bowler. A batsman hits back a ball straight in the direction of the bowler without changing its initial speed. Without changing its initial speed of 12 meter per second. The initial speed of the ball by which it is thrown is 12 meter per second. If the mass of the ball is 0.15 kg, if the mass of the ball is 0.15 kg, if the mass of the ball is 0.15 kg, then find the impulse imparted to the ball. Then find the impulse imparted to the ball. We have to calculate the impulse and assume the linear motion of the ball. Assume the motion to be linear. So what impulsive force imparted to the ball? This we have to calculate. So what we have given? We have given a batsman hits back a ball straight in the direction of bowler without changing its initial speed of 12 meter per second. Initial speed of the ball is 12 meter per second. If the mass of the ball is 0.15 kg, if the mass of the ball is 0.15 kg, then find the impulse. J we have to calculate impulse. So suppose here is batsman and here is the bowler. He throws the ball in the direction, in this direction, and batsman hits back the ball in this direction. So the direction of velocity was 12 meter per second, which we have taken initial velocity, and it would be sent back. The ball is sent back by the same initial velocity which we have given, without changing its initial velocity. A batsman hits back a ball straight in the direction of bowler. This is the position of batsman and this is the position of bowler. So bowler throws the ball with a speed of 12 meter per second and batsman hits the ball in the direction of bowler without changing its speed. But direction gets changed. If this direction is taken as positive, then the V would be taken as negative, minus 12 meter per second. V is the final velocity and U is the initial velocity. There is no change in the magnitude of the velocity, but its direction gets changed. And we know the formula for impulse equals to change in momentum. Change in momentum means mass is fixed. There is a change in velocity. V minus U, not in magnitude but in direction. So the mass is 0.15. Velocity V is minus 12 and velocity U is 12. So decimal gets cancelled. 15 upon 100 into minus of 24. 6 4 jar 24, 25, 5 jar 100 and 3 and 5. So we get minus of 18 by 5. Minus 18 by 5, which is equals to minus 3.6 Newton second. Because impulse equals to force into time, the unit of force is Newton, the unit of time is second. So this is the impulsive force, minus 3.6 Newton per second. and the negative sign shows minus sign indicates that the direction of impulse, the direction of impulse is from batsman to bowler, from batsman to bowler. Minus sign indicates that the direction of impulse is from batsman to bowler. Now let us discuss another question. Question number 2. The graph is given. Question number 2. The initial speed of a body of mass 2 kg is 5 meter per second. Initial speed. Initial speed of a body of mass 2 kg. Of a body of mass 2 kg is 5 meter per second. Mass is given, its initial speed is given, a force acts for 4 seconds. A force acts for 4 seconds. A force acts for 4 seconds. A force acts for 4 seconds in the direction of motion of the body. In the direction of motion of the body. In the direction of motion of the body. The force time graph is shown. We have given the force time graph. This is the time axis and y is the force axis. 1, 2, 3. The force in Newton, 1 Newton, 2 Newton, 3 Newton, and time is 1 second, 2 second, 3 second, 4 second. 1 second, 2 second, 3 second, and 4 second. So time is in second and force is in Newton. This is 1.5 seconds and the graph is like this. Then from 1.5 to 2.5 the force is constant. There is a constant force from 1.5 to 2.5 seconds. From 1.5 second to 2.5 second, there is a constant force. Then from 2.5 to 3 seconds, the force decreases from 3 to 2. The force decreases from 3 Newton to 2 Newton. From time 2.5 to 3 seconds, the force decreases from 3 Newton to 2 Newton, then up to 4 seconds, the force is again constant. Up to 4 seconds, the force is again constant. So this diagram we have given O, A, B, C, D, E. O, A, B, C, D, and this point is E. And this is the point A dash, B dash, C dash. So we have given the initial speed of a body of mass 2 kg. Mass is 2 kg, its initial speed is 5 meter per second. A force acts for 4 seconds in the direction of motion of the body. Up to 4 seconds, a force acts in the direction of motion of the body. So calculate the impulse of the force and final speed of the body. Calculate impulse of the force. Calculate impulse of the force and second final speed of the body. Final speed of the body. So we have studied graphical method. To find the impulse, we will have to find the area of this figure. To find the impulse of a force, we will have to calculate the area of this figure. So let us calculate impulse of the force. Impulse of the force is equals to area of the figure. So area of triangle. This is triangle. Area of triangle OAA dash plus area of rectangle A dash AB dash A dash plus area of rectangle A dash A B and B dash plus this is the trapezium plus area of trapezium B dash B C C dash and plus again this is a rectangle plus area of rectangle C dash C D E. Now the area of triangle is found by half into base into height. Height is 3, base is 1.5. So half into base 1.5 into height is 3. Then area of rectangle length into breadth from 1.5 to 2.5. This is 1 and this is 3. So 1 into 3. Then area of trapezium half into height into sum of parallel sides. 1 by 2 into height. Height is from 2.5 to 3, which is 0.5. And sum of parallel sides. This side is 3 and this is 2. So 3 plus 2. Then the area of rectangle 3 to 4. This is 1 and this is 2. So 1 into 2. So we get 1.5 into 3. 4.5 upon 2. Means 2.25. 2.25 plus 3 plus 0.5 means 5 by 10 into 5 into 1 by 2 plus 2. So 5 into 2, 10. So we get 2.25 plus 3, which is 5.25 plus 5 upon 4, 5 upon 4 and plus 2, and which is 5.25 plus 1.25 plus 2. So this is 6.50 plus 2, 8.50. 8.50 Newton second. This is the impulse. 8.50 Newton second is the impulse. So first part we have calculated. Then we have to find the final speed of the body. So final speed is given by delta V equals to impulse upon delta V equals to impulse upon mass, because impulse equals to change in momentum, mass into velocity. Impulse we have calculated and mass is already given, which is 2 kg, so it becomes 4.25 meter per second. 4.25 meter per second. This is the change in speed, and final speed will be, this is the change in speed. Final speed is found by adding the initial speed. So 5 plus 4.25, this is 9.25 meter per second. This is the final speed. So we have calculated the impulse of a force and the final speed.